This is part 2 of section 5.2. We have another system of equations with 3 variables, 3 equations, and our numbers aren't so pretty here, but that's okay. We just need to be careful with them and double check everything. I'm going to label these 1, 2, and 3. And our first step is to take equations 1 and 2 and eliminate a variable. And remember, what we choose to eliminate for 1 and 2, we're also going to need to get rid of on 2 and 3. So be aware. I don't think there's anything particularly nice in this entire equation, entire system. So I'm going to choose to get rid of x. Okay? So if I look at 2 and 3, the common denominator, if those were denominators, would be 6's. So if I turn the 2 into a 6, I would multiply it by a 3. To turn the 3 into a 6, I would multiply that by a 2. Now, this gives me a positive 6 on each of them. And I really need a negative 6, so I'm going to make this 2 a negative. I could make the 3 a negative. It would also work. Okay? So now I need to multiply a 3, everything here in equation 1 by a 3. That gives me 6x plus 9y plus 21z is equal to 39. Now I'll multiply everything in equation 2 by a negative 2. That will give me negative 6x minus 4y plus 10z is equal to positive 44. Now combine, the x's go away as we designed, and we have 5y plus 31z is equal to 83. We need this equation, but we're not ready to use it. This is my equation number 4. Now I go and I pair up 2 and 3. I got rid of x here, so I need to get rid of x again. 3 and 5, I can easily turn those into 15s. If I multiply equation 2 by a 5, I'll have a 15x. Multiply this by a 3. And again, I'll have both positives here, so I'm going to choose one of them to be negative. And again, it does not matter which one. Multiply this entire equation by a 5. You get 15x plus 10y minus 25z is equal to negative 110. Now multiply this entire equation by a negative 3, and you get negative 15x minus 21y plus 9z is equal to, it's going to be positive 84. Our x's go away again, and now combine like terms. And we have 10y minus 21y, which will be negative 11y. This is minus 16z is equal to negative 26. And I'm going to call this equation number 5. Now the whole purpose for doing this was so we'd have 2 equations with the same 2 variables, and we do have that. Now we pair these up, and we need to get rid of a variable again. Well, again, nothing looks particularly nice here, but 5 and 11 are smaller numbers than 16 and 31, so that's what I'm going to choose. I'm choosing to get rid of y. So with an 11 and a 5, I can make those into 55s, and they already have opposite signs, which is nice. To make this a 55, I would need to multiply this by 11. And I would need to multiply this one by a 5. Okay? Multiply everything here by an 11. So this is 55y plus 341z equals, that's going to be 913. Multiply all of this by 5, and you get negative 55y minus 80z is equal to negative 130. I'm working an ugly one here so that you can understand that you should not panic just because you get some ugly numbers. Those cancel, combine like terms, and you get 261z is equal to 783. Divide both sides by 261. And you'll get z is equal to 3. So I have one of my 3 parts. Now I need to take this value and plug it back in someplace where I can get another answer quickly. And that would be in either 4 or 5, because I know if I know z, I'll be able to figure out y. So, and I can plug into either one, but I like the numbers in 4 better. So I'm going to choose to plug into 4. And again, this could have been, or 5 right here, whichever one looks easier to you. So this would be 5y plus 31 times 3 is equal to 83, which is 5y plus 93 is equal to 83. Subtract, 5y is equal to negative 10. Divide both sides by 5, so you get y is equal to negative 2. One last step, I need to find x. The only place we still have x's are in 1, 2, and 3. So just pick one, and I guess I'm going to choose number 1. The numbers are a bit smaller and there aren't negatives involved. That's just a reason, not the best reason or the only reason. But you could have gone into 2 or 3 at this step and it should work out. This would be 2 times, I didn't leave myself quite enough room here. So 2 times, 2x, which is what we still don't know, plus 3 times y, which is negative 2, plus 7 times z, which is 3, is equal to 13. So this is 2x minus 6 plus 21 is equal to 13. This gives me 2x plus 15 is equal to 13. Subtract 15 from each side. We have 2x is equal to negative 2. Divide both sides by 2. So x must equal negative 1. So now we have x, y, and z. We have our answer. If we were to graph these 3 equations in 3-dimensional space, they would all intersect in exactly the point negative 1, negative 2, positive 3. I do strongly suggest that you take each of these values and you check it in each of your 3 original equations. Remember, it has to work in them all. I believe the way I have the homework set up is it will lock the correct answer. So I believe this is set up this way. So if you got z correct but got y and x wrong, you will know. So you would know you were correct up to here and you made a mistake right in here. Or, some other combinations of things. Like I said, I believe that's how I have it set up. It's how I intended to have it set up. And if you notice that I don't, also send me a message and I will make sure that that happens.